So what we're going to deal with is your BLAST lab, or at least a part of it. So here's the write-up. It's nothing too absolutely terrifying, but I want to walk you through at least the second part. So if we go to this website, so what this will allow me to do is look up any type of gene I want. So I can pick whatever. Let's do Rubisco. Why? Why not? And what we'll get is something that looks like this. So 254 of these pages. So we could have fun with this. And what they'll tell us is where these are coming from. So here's the name of the gene. Description, okay, here's what they're going to call it. So ribulose bisphosphate, carboxylase small chain, chloroplast light, okay. And we can sit there and go through which ones do we want, but let's go with this first one. So Cucumis sativus, which is the cucumber. It's found on its 5th chromosome, blah, 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 blah. So what I can do is, if I click on where it says name, the RBCS, you'll think about it. And what I'm now going to start getting is a whole bunch of information. The one I'm going to want is the reference sequences, which is over here on the right side. So it's going to drop me down to here. In particular, what I'm going to want to hunt for is mRNA and proteins. If I click genomic, what that's going to give me is the entire genome. So it's going to give me a massive piece of chromosome, and that's not what I want. If I look down here, there'll be something that says like XM or something along those lines. Yeah, that's a good one. If I click on it, what it's going to give me is, well, this one is what we think it's going to turn out to be, but we can run with it. That's going to give us all sorts of information on it. So what the organism is and its classifications, what people are thinking about stuff. This one, here it is. They'll have something down here that'll include something that says translation. It's going to then have all of that junk there. That's actually the protein sequence. So methionine, then alanine, then a serine, an isoleucine, a leucine, a serine, an alanine, valine, alanine, serine, blah, blah, blah. So that's what this turns out to be. This origin piece here, that's the gene. So I'm going to steal it. Copy. What I'm going to do is take that into this piece here, the actual BLAST. And what the BLAST will do is it's a comparison. All it does is if you give it information, it will compare it. So I stole some nucleotides. Let's go to the nucleotide BLAST. And we type it in. This part I've never been entirely sure of, so I'm always paranoid, and I just get rid of the numbers. The numbers shouldn't matter, but I'm paranoid. Hooray. So now what I'm going to ask it to do is search for it. So I hit BLAST. It's going to stop and it's going to think. How big the piece of DNA turns out to be will determine how long this takes. So if I put in the entire chromosome, number 5, for the cucumber, this could take a very obscenely long time. Excuse me. Turned out to have 1,000 nucleotides, and what I got is this. So if I scroll down, these are the matches listed in order. So the E value is a nice way of saying how close are we. So if we get an E value that is e to the -4 or smaller, so e to the -174 is obviously smaller than e to the 4th, what that's saying is, hey, this is a pretty good match. So when I start getting down, say I don't even see any of the numbers down here, that would be horrible. But what we turn out to have are, here's where we think it turns out to match. And shockingly, it's 100% match to the cucumber. So I would have hoped it would have done that, and it was even 100% matching the predicted one, which is what we took. But we could also start looking for like this one, which is some other type of cucumber. or this guy here, the Cucurbita pepo, whatever that organism is. Or we could start scrolling down and seeing, do we have even other choices? So if we start looking, we start to see other organisms that are down here. I know that one's nicotine. Brassica, that's some type of cabbage. Brassica rapa, hey, that's the thing that you guys are growing. And it turns out to have a 77% match, but it's still a pretty good match. So what we can do is start to hunt for organisms. If I wanted to try this again. So if you notice, all I did was I just refreshed the site title, the URL. So another thing I could do if I were curious, but this one becomes a little bit trickier. And I don't necessarily recommend it for the lab that you're going to be doing, but heck, why not? What I can do is I can say what organism I want them to look for. So if I wanted Arabidopsis, it's now going to hunt just for Arabidopsis. And maybe there'll be stuff and maybe there won't be. I don't know. This might not be promising because it's still going. Yeah, this mightn't have been a bad choice. Oh, there we go. Eventually it popped through. We only got 2 values. So we have one for, and neither of these are typical Arabidopsis, but we got E values. So it's a way of saying we can actually hunt for certain organisms if I happen to know where it is. This is showing, how nicely did they align and things like that. So that's the basics of how do you do this. Then you can go back and we could try again. So which is you go up here, take all that stuff away, and you just type gene. When you do that, we're back to where we started. And you can do this over and over and over and over and over again. At least until you have fulfilled the requirements of the lab.